Welcome, or hopefully welcome back to the Reliability Matters podcast. For those of you who are counting, this is episode number 167. Today, we're diving into the world of the electronics manufacturing industry. Well, that's not unusual for the show, but this time it'll be from a unique vantage point, that of the press. My guest today is someone who has spent decades at the forefront of reporting on the electronics manufacturing industry. Mike Buetow, editor-in-chief of Circuits Assembly magazine, has covered everything from the latest technological advancements to the biggest challenges facing manufacturers today. If there's a major trend shaping the industry, you can bet Mike has written about it, analyzed it, and spoken with the experts behind it. Mike is also the host of his own podcast, PCB Chat, available at pcbchat.com. And I'm so proud to say Mike also syndicates this show at pcbchat.com. On this episode, we'll explore the evolving landscape of electronics manufacturing, from supply chain disruptions and AI-driven automation to the future of ultra-high density interconnects and the real impact of reshoring efforts. We'll also get an inside look at what it takes to cover this ever-changing, fast ever-changing industry, how stories are chosen, what topics are making waves, and what challenges lie ahead. So let's get into it. My conversation with Mike Buetow begins in just a moment. Stick around.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Hey, Mike Buetow, welcome back.
Thanks, Mike. And honestly, I really appreciate that introduction. It feels really weird to hear, decades of experience at this point.
I know. I don't know if that's a compliment or a slide, but
yeah, I swear, back in the day, my hair used to be a lot more red. My face has always been red. That just goes with the territory as being a journalist, right? You're always red-faced because you always make mistakes. But, so be it. That's aging.
It's funny. Years ago, my beard kind of went gray. My mustache and beard went gray. My hair hasn't for some reason, but I can't tell you how many people will come up to me and go, "Hey, I got a question about your podcast." I'm like, "Oh, yeah, sure. What's that?" And he goes, "How come you dye your hair and you don't just bother? Why don't you just dye your whole face?" That's just God's sense of humor, my friend. That's all it is. It is what it is, But I don't know. First world problems here. It could be a lot worse.
There's been a time or two where I thought it might be safer if I just walked around with a bag over my head. Just go more anonymous. That might just be, not everything you write, or not everything you say after 35 years in the field, pans out. And sometimes you're like, oh, man, I really wish I hadn't said that.
Yeah, well, that's the problem with content creation is, podcasts specifically. Once you say it, it's there forever, and it's evergreen. It doesn't die. So yeah, so I try and not. I ask all my guests to make predictions. I don't make predictions because, they come back to haunt you many times. I was going to update the intro, but instead of updating the intro, I'm going to add another accolade to your war chest of accolades, and that you're the president of the PCEA, Printed Circuit Engineering Association. Tell me more about that association. Is it brand new? Is it new? Did you just take over something that was already existing? Tell me more about that.
Right. So PCEA has actually existed since 2020.
Okay.
It was formed by the folks who used to be part of the Designers Council. That was an activity that was supported by IPC. And in fact, I had been involved in that way back in the day, early, mid 90s. That organization kind of, it was a bit different than the typical setup, in that it was more of a society inside of an association than an association itself, right? Because it was really member driven by individual members, not by corporate members. And so, around 2020, they spun off, created their own association. And at that point, it was all volunteers. There was about a dozen or so directors, and I was brought on as one. That time, we were part of UP Media Group, which was a standalone, privately held company. And in late 2021, we engaged with PCEA, engaged with UP Media Group about a possible acquisition. And that was culminated in January of 2022, at which time I moved from being the editor-in-chief of UP Media Group to the president of the PCEA.
But you didn't.
And it was an interesting start. I mean, because they didn't have any actually, they didn't have any employees at that point. They didn't have anything really in terms of revenue streams, just kind of volunteer donations. And the board was made up of folks who had been primarily, although not exclusively, folks who had worked for somebody else, right? They weren't managers. They weren't people with tremendous financial or business experience. They just had a lot of passion. And, we fit that mold very well.
Yeah, you do. There's, several associations within our industry, but I would say, the primary ones that people kind of just know the names of, even if they don't understand what they do exactly, would be IPC, SMTA, and I think PCEA is certainly becoming one of those as well. And we each have, although we overlap in certain areas, kind of at the edges, there is a core that's quite different at least between SMTA and IPC, where IPC is very standards centric and training and certifications, things like that. SMTA is chapter based and mostly associated with assembly, although that's, we have overlap at the edges. I just got back from the wafer level packaging conference in San Francisco. And before that, I was in Arizona for the ultra high density interconnect symposium. So those are kind of newer for SMTA. What, if you were to kind of pigeonhole, which may not be a fair question, but if you were going to pigeonhole PCEA, where in the spectrum of electronics manufacturing at large would its core be?
Right. So we believe that everything starts with design. And that was the background and experience of the folks who founded the PCEA. And we continue to use that as our launching point. Most of our content is aimed at the design or design engineering professionals. Of course, everything sort of evolves from that, right? Because we are part of a very wide supply chain.
Yeah.
And so we have procurement people, we have fabricators, a lot of fabricators, we have a lot of assemblers that are part of the organization, either as individual or corporate members. But I would, if you want to sort of articulate what our goals are, it's to improve the professional career of circuit board designers and engineers, right? So, how can we raise them? And it's really kind of a bottoms up type of organization. So we focus on the individual and, how we can help them as they navigate through their career from a technical standpoint and also from just a job management standpoint, because a lot of folks don't have the mentors within their own companies that they used to. The bench strength is nothing like it used to be. And so folks have to look outside their own organizations for that kind of career advice. We like to think that we bring that to them. I would say that, at the core of what we're trying to do is to take design principles, new design concepts and good fundamental design concepts and help push them downstream to manufacturing, while also taking those manufacturing constraints, which, as everything kind of depends on whether you can build it or not, right? We can come up with any design we want to, but if it's not buildable, it's not reality. So we want to make sure that those design constraints are moving back upstream and communicated to the designers, so that they're not just
that's amazing
scrap.
Because the analogy I like to use for our industry is we are all in a village along the same river, and there's the board design village, there's the PCB fab village, there's the assembly village, and then there's little micro villages within the villages, like little suburbs and cul-de-sacs and things like that. And we're so siloed that, and I've said this many times on the show, so for my audience that's heard it, sorry, I apologize. But, I think in the assembly world, we believe that PCB printed circuit boards are delivered by storks. They just fall magically from the sky onto our loading dock. They just appear, and components same way. And it's funny how our industry works. And I'll bet all industries are this way, but certainly I'm aware of it here, and I'm sure you are. And that is, all of a sudden we get a new package. Let's go back to BGAs back in the day, and the assembly guys, open up the package and they go, "What the hell do we do with this? All the connections are on the bottom. How are we supposed to do this?" And then we spend the next 10 years plus in conferences talking about, how to mount that stuff, how to actually assemble it, how to get it to stick to a board. And then, well, wait a minute, how do we inspect it? Okay, we'll come up with a solution for that. And then, well, how do we clean it? And then we come up with a solution for that. How do we test it? Et cetera, et cetera. And it would be Pollyannish to think that we could do this, but it would be really nice if when the component design people, when the fab people, when the interconnect people, when the board design people, decide they're going to start with a new project, talk to everyone in the village. But there's just not enough time in a day for that, right? Because they're all way down technical rabbit holes, and they all have a specialty, and they all have different priorities. And the priorities for assembly people are way different than the priorities for design people. And we can't know all that. We'd have to all be prodigies if we had that kind of experience. So it's an interesting business to see. It's like Christmas Day. What are we going to get as a present today? And now what are we going to do with it?
So I listened to your podcast, right? And I have heard you make that analogy before. It's the thing about it is, right, is that the analogy holds if we remember that what that stork is bringing is unique to that particular program.
Yeah,
right.
Absolutely.
So every board is unique to a program. It's not like Intel that's building billions of,
right.
A particular microprocessor.
Yeah.
And they all look alike, they all perform alike. And this is a very different thing. And so, and find the parent who would say, my kid is exactly like yours.
Right. Right.
So
they'll all say very similar, but ours is better.
But that's why the analogy works, Mike. And that's what makes it so complicated, because, the board fabricators and the designers, for that matter, aren't building a common module that can then be used over and over and over. And
right.
Whereas they may use known good, they may reuse certain design paths. You use a particular part, and what the spacing should be, and how to do the breakouts and things like that on that particular BGA. And that's all great. I mean, we should do that. There should be a lot of design reuse where it makes sense. But the functionality, the form factor, all that kind of thing varies from product to product.
Sure.
And so, every time the board is going to be different, and what the fabricator has to deal with is going to be different, and thus what the assembler has to deal with is going to be different.
Right. And
yes, the component manufacturers do a great job of coming up with new packages to make our lives that much more
challenging. Yeah, interesting is a good word. It's also a difference in focus, where the designers are coming up with a unique solution to a new problem or a new challenge. So it's they got to kind of clear the field, start over in many ways. And when you get to the contract manufacturing world, their nirvana would be the line moves at the same speed for every customer. The oven is set to the same profile for every customer. The print pressure and all that is the same. I mean, that would be nirvana, right? That way it's like assembly line, even though they're all completely different products for completely different tasks. The motivation would be to try and make all the processes as similar as possible. So when something unique does come that requires a step stencil or versus whatever, or window painting to avoid the voiding created by the design of the product, or whatever the case may be, it slows down the process. And particularly in the CM world, it's so competitive. It's the CM people would hate to hear this, and it's probably not technically accurate, but it's been commoditized by buyers. Board fab is probably the major example of something that's just you get a contract or you lose a contract over half a cent a board. In many cases. So we want familiarity, we want consistency, and when something new comes up, it's a definitely a wrench in the gears. But anyway, so we talked about association.
Mike,
yeah, go ahead.
right. Mention though, don't you think though that the fact that every program is different and there's not a lot of commonality in terms of what that design, the way to build that design is actually to the advantage of fabricators and assemblers, okay? Because it allows each company to come up with its own innovations and processes whereby instead of just being simply the lowest cost provider, where it's all just labor rate, right? In which case, certain regions simply would never be able to compete. There's other factors that are at play. And, and I mean, I think that that's part of the beauty of it, right? I mean, we've been hearing about consolidation in the industry forever, but and it's happened to a degree, but really what's happened is it's migrated. It hasn't shrunk. Okay. The industry itself grows. The number of companies is actually growing. The OEMs are building their own product again in many cases. Like, there's so many different models. It's almost like, for every EMS company you could look for, if you've seen one EMS company, you've seen one EMS company, right? There's a model that's unique to almost every one of these guys. Yeah. Even if you look at the top tier guys, Foxconn's model is different than Pegatron's, which is different than Flex's, which is different than Celestica's. They're all different. Yeah. And that's kind of one of the beauty of it as a journalist, is that you can look at all these different organizations and say, here's what they're doing. Here's kind of their secret sauce. Now, let's spill that to the world and see if you can replicate it, because it's not easy.
Yeah. Not just do they have specialties in their technological capabilities? There's also, I'm friends, and I've had a guy on my show before that has a small family-owned CM that concentrates on prototypes and small runs. I mean, 10 boards is nirvana for them. Go to Foxconn and ask them for 10 boards. It'll be the same as 110 million boards, same cost per board. I mean, in terms of overall cost, not cost per board, because they can't do that, unless, of course, they're doing it for Apple, and they're then going to get a billion board contract after that. But, they all have their specialties as well. So you've been covering electronics manufacturing, well, since I've known you, which has been decades, as we talked about in the intro. Yeah, we said the word again, decades. What are some of the biggest trends in the moment, at this moment, that are shaping the industry right now, or influencing the industry, or pain in the butt for the industry, whatever the case may be?
Well, yeah. So certainly there is the ever-shrinking form factor. And you probably saw this last fall, maybe, earlier this year, what Murata announced, the 006, 003, their MLCCs that they've come out with. And so, we're looking at something that is considerably smaller than an 008, 004, right? I mean, that's, it's mind-boggling. They're making the old metric 0201s look like child's play. And so all of the assembly issues that are going to be involved with placing those parts, soldering them, right? But even getting the paste down, right? Because you're gonna have to dispense that. Printing that is probably not going to happen. Making sure that the nozzles are correct from the SMT placement size, so that you can actually put these things down. Making sure that nobody breathes too heavily, so you're not spilling them all over the place, because you'll never find them again.
Yeah.
Then the inspection, and of course, where you come in, the cleaning. I mean, good luck, right? So, these are really complicated components, and I mean, they are more aspirational right now than reality, but they'll make it through.
But they all start that way. And then they become our normal, right? Mm-hmm. And at some point, we'll look back at these new parts with envy. Like, I wish we can go back to those parts. Those at least we could see under a microscope. Now it's it's at atomic level or something.
Well, I mean, which gets you into the next thing, which is, okay, so we're going to be looking at different types of solder bumping and balls, whereby we can, put down, very, very small leads onto the parts and go, directly to the board, or perhaps we're going to, go from die to package to board, or perhaps we're just going to skip the package altogether and just go the solder bumped die, eliminate the package material, and go from there, right? And you look at, I think it's EPC, their CEO Alex Lidro was the co-inventor of the silicon power MOSFET back in the 1970s. Like, he's still around designing these new types of packages. It's really, really cool. A little scary, but again, it keeps us on our toes. And not just the assemblers. I mean, the designers have to figure out, how are we going to come up with the lay-in patterns for these? How are we going to route them? These are not simple things.
Yeah. Is Moore's Law dead? Is Moore? No, he's not on life support, Gordon Moore. No. Okay. So I've heard that I've heard the statement be made, or more in a question form, but a little bit of editorializing within the question, that Moore's Law. We may be way past Moore's Law, or maybe we'll take the 2 years and make it 4 years, or modify Moore's Law. But you think we can still keep that basic spirit of Moore's Law going for longer?
Right. I mean, the Moore's Law has been sort of morphed over time to say, hey, look, the number of transistors will double every 24 to whatever months, every 18 to 24 months. Okay. The density. But really, I think what Moore was getting at had to do with the cost per transistor. And, the whether or not the integer, on that access, continues to be, 18 months, 24 months, or some other, duration, the general spirit of it is absolutely correct, which is the cost per transistor is going to continue to go down. The size of, or the density of the transistors on a die will continue to shrink. And those things are constantly changing, right? Yeah. So, and they have to. So, I mean, we're only at the mercy of, companies like ASL in the Netherlands and TSMC and some of the other packaging guys, insofar as what they can, how fast they can continue to build equipment to do this, and how fast the lithography can keep up with it. But they've done a great job so far. I mean, again, we're at the 006, 003 level now.
Who would have thought? So I think Gordon Moore may have backed himself into a little bit of a corner by putting a timestamp on his prediction of 24 months or so, doubling. I think the greater takeaway, exactly to your point, was not that it would necessarily double within that time period, but the results of that would be greater efficiency, much higher computer power, smaller packages, and that, I think you're right, that is not dead. Whether it's 24 or 36 or 48 or 10, it really, that's a distraction. To me, it's all about our processing chips, our computers. I should say computers. Are they faster today? Yes. Are they cheaper today? Yes. For the power that you get, they're relatively cheaper today. Are they smaller? Oh yeah. To the point of pain threshold. Let's switch topics a little bit and talk about kind of the growing elephant in the room, which are tariffs. We're back. I feel like we're watching Poltergeist. They're back. All of a sudden, tariffs are the word du jour. They're this proposed solution to every problem. And of course, tariffs fall on ultimately the consumer, and they do affect the manufacturer, obviously, because it could slow down sales and things like that. But it's paid for by the recipient of the product. How do you view tariffs landing in our industry specifically? Are they a threat? Are they a throttle to growth, or are they just something that the industry will just deal with, and hopefully in 4 years they'll go away or less?
Right. So just so that the listeners understand, I'm not an economist. Okay.
Right.
And PCEA is not a business or a lobbying organization.
Right.
Yeah, we're focused on the technology and the professional networking.
You're not taking a stand. You're not editorializing on a position.
Correct.
Yeah, me neither. Correct. I'm just the practicality of it.
Right. So what I see is that it creates a whole lot of uncertainty for businesses, and not just month to month, week to week, but it can be day to day and hour to hour. There's quite a few contract assemblers in the Boston area. Many of them are multinationals, and I've spoken to them specifically about this issue, and they are left scratching their heads over what to do, what to tell customers, where to build product. If you have a plant in the U.S. and one in Mexico and one in China, now what do you do, right? Because you can't just necessarily move programs from one to the other, because sometimes those plants are set up to do different things. That the components and everything else are in different places. You can't, snap your fingers and make this happen. So besides the cost uncertainty and the potential hits to the bottom line, because I think what's happened in most cases is that the tariffs haven't necessarily been passed along dollar for dollar to customers.
Yeah.
You have the logistics uncertainty, and that is going to back up in a lot of ways. I have demand for my factory in Texas, but right now, I don't know whether my factory in Mexico, which takes on, most of my volume, is going to be able to build this product without having been hit with a 20-25% increase in the cost. So do I move it to Texas? And if so, do I move equipment, my SFG line from Mexico to Texas? Or do I buy additional lines for Texas? Even though, they may only be miles apart, you've just really complicated that business. And then what about the equipment suppliers? What are they supposed to do insofar as, where they're shipping machines? It's unnecessarily complicated the business landscape. And I'm not really sure how this is all going to fall out. But it's an uncomfortable position to be in. And it's not just a U.S. position, right? I mean, because India is doing it, and China is doing it. And, this is reverberating all over the place.
Yeah. Yeah, and it's complicated. There was a lot of emphasis on, from the civilian understanding of our industry, everyone's talking about the chip shortage, and they're not talking about Doritos. They're talking about, semiconductor stuff. And, what most people don't realize is, why don't we build fabs here? Okay. Well, we are, but we don't own them. I mean, they're, TSMC's, building out here and a few other companies. But if the U.S. decided, okay, we're going to build a fab shop, we're going to fund it 100% by taxpayer money. Let's just make that hypothetical. Okay, you're invited to the grand opening in 7 years. It's so complex, and there's so many moving parts. I mean, they're a couple years in permitting. They're a couple years in laying foundations and building walls, and they're a couple years at bringing in all the equipment, and then they're a year or two in qualifications and calibrations and testing, and it's years before you can turn the key. And in the last 7 minutes, our industry's changed. That's a huge investment for something that is very fluid at this moment, and it's not a quick fix. It's so expensive. It's almost government scale money if you really want to do it, because no one company, Intel's not going to build a brand new state-of-the-art TSMC rival tomorrow, right? They do what they do. That's their niche, and I don't know. It's a huge amount of money and a huge amount of time for an industry that is evolving so fast. There's only a handful of non-mortals, that can carry that out, right? It's not a quick fix.
So the permitting is a real issue, and particularly in the U.S. Because you have local, you have county, you have state, you have federal, all sorts of different regulations, but you have to cut through that maze of paperwork. And this because you've built your own. And when you're talking about fabs here, you're talking about semiconductor fabs, but it's the same for bare board fabricators as well. And it's one reason why you don't see a whole lot of them popping up in the U.S. I mean, there's the cost for the equipment and all the permitting and all the treatment, wastewater, recovery and so forth that you have to go through. But then there's also the labor issue. And I would argue that, Intel, could put their plant in Ohio, which they've received, government incentive to do. And yet they will not be able to close the gap. They could outfit it with all the exact same equipment that the state-of-the-art guys, the TSMC and Samsung have, but they will not be able to close the gap, get down to that 2 nanometer type of processing unless they find the right people too, because it's process based. It's not just equipment based. If it was equipment based, everybody would be doing it.
Right.
But it's also understanding the process, and that's really where it gets very complicated. So I would, and then how are you going to find those people? Right now we have 3% or therefore thereabouts unemployment in the U.S.
Right.
How are you going to find the people to work in these factories that you want to ramp up in the United States or any place for that matter? Because in most regions, I think that there is a capacity crunch when it comes to labor. Thailand imports workers from Indonesia and China, right? It's just you can't just go to a third world country and say, okay, there's lots of untapped labor. It really hasn't worked that way.
Yeah, you're absolutely right. Are we through the worst of the supply chain? And from your vantage point in the crow's nest, are we through the worst of it, or do you think it's
in terms of
pause?
Availability?
Yeah, in terms of availability and ships stuck off the coast can't get unloaded, and all the different the perfect storm of events that we had that kind of led to that. Including the shutting down of the world economy. Turns out that car, if you don't run it often enough, doesn't like to start back up very easily. So I think there were many external factors that triggered it, which are yesterday's news in many cases. Do you think we're through the worst of it now?
So from that standpoint, yes. There's not an EMS company I speak with that doesn't have one program or another that doesn't make shipment because of a particular part that they can't get. But broadly speaking, it's that part of the supply chain stoppage has been smoothed out. Component distributors have way more inventory than they really want right now. But there are what I would call micro issues that are popping up that are more concerning. And so I'll give you an example. At the end of November last year, the last remaining copper foil manufacturer in the U.S., supplying to the printed circuit industry, announced they would be closing, and that's a big deal, right? Because guess what? Every circuit board has copper foil. That's your metal planes. So that's a problem. And, if you want to have supply chain resiliency, if you want to have a secure and stable supply chain, in a particular region, then you need to have the entire, all of those individual suppliers available, locally, or at least in friendly and contiguous regions. It wouldn't be a big deal, I guess, if it's coming from Canada to the U.S., but if you're relying on it to come from Taiwan into the U.S., if there's a problem, that's going to really kind of curtail your ability to make lots of circuit boards for, military equipment, planes, missile systems, and so forth in a hurry if that's what you need. So those are the things I worry about, right? When you get down to just having one or two suppliers of a particular but critical component or chemistry material, and they say, hey, look, I can't make money doing this, I'm going away. Now you're reliant on maybe not so friendly or accommodating business partners to supply that, and you become subject to their whims.
Yeah. Remember during the absolute, the madness, chaos, confusion that the pandemic created, the ripple effects of the pandemic created, not only were there shortages of parts. If you could find a place overseas that had the part, there was a shortage of containers to put the parts in because the containers were all stuck here in our ports, and ships couldn't, they had to wait sometimes 3 months to get unloaded, and that just tied up the containers, and the container manufacturers couldn't respond fast enough to build more containers. It was just a crazy thing. I mean, not only did we not have the parts, we didn't even have a box to put the parts in. It was complete madness.
Right. That was a real problem. But I mean, I think back to, again, here I'm showing my age, but the early 90s when ECN, which is, the epoxy that's used in every semiconductor package. And there really were only a couple major suppliers in the world of that. And one of them was Sumitomo in Japan. And they decided that they were going to get out of the ECN business. And keeping in mind that they had 60% market share at the time. And yet they couldn't make money. And that's what I worry about is the financial implications. If you're the only copper foil manufacturer in the U.S. and you can't make money, then that is the bigger issue. I'm not sure how to fix it. Again, I'm not an economist,
right.
and I'm not going to kind of stick too deep into that one. But there are the U.S. government has tools where it could force businesses to stay open if it is seen as critical to our government supply chain. In this case, I don't think that that's really gone anywhere. But the bigger issue, the prevailing issue, really is how many more of these things have to disappear before we decide that we need to take a different approach. Right? We're down to just a couple laminate manufacturers. We're down to one drill manufacturer. We're down to one plating manufacturer. We have one pick and place manufacturer on the assembly side, right? So I mean, how are we going to manage if we get into a trade war and all of a sudden that machine coming from Europe or from Asia is twice as expensive as it used to be because of tariffs and shipping costs and everything else that's getting slapped onto it.
Yeah. How is AI, artificial intelligence, landing in our world from your perspective?
Not well. So it's a really interesting technology, right? When we think of AI, in my opinion, with what we're talking about really is automation. And from the design side, there are most of the major CAD vendors and lots of startups have come up with AI-based tools or algorithms that will allow them, I'll say models, right, that will allow them to perhaps automate or speed up some of the tasks that your typical print circuit board designer would do. And I'll get to assembly in a moment, but what we're seeing is that there are definitely limits or constraints to what these programs can do. And one of the big issues is that within any particular design, there is no one way to do things. A lot of it involves trade-offs, the manufacturing constraints, the material constraints, the spacing constraints, and understanding what you can live with and what you can't. And that comes down to designer knowledge. So we've had auto routers on CAD tools for 30 years, but if you talk to designers, I mean, every time we have a conference and we ask people to raise their hand, how many of you use the auto router? Very few do, and almost none of them use it to completion. So when we're looking at AI and we're thinking in these same terms, like, well, people are skeptical and they have reason to be. What I do think that AI is really good at is crunching large amounts of data very fast and helping you kind of sort through and find what you need. And we do see that already on the assembly side. So, you've got your EMS factory and you're building, thousands, if not millions of solder joints in a given month. And the AI can sort through all that and find trends that you may not otherwise have been able to discover. It's, again, not perfect. And I've talked to plenty of folks who have tried to implement these systems and they've spent a year and a half, maybe 2 years trying to get it up and running. And they're just banging their heads against the wall as to why it's not working correctly. So with every technology, I think you were involved in the roadmaps back in the day. I mean, we know this. It takes a long time to go from idea creation to implementation to mass acceptance.
Yeah.
And we are, traditionally that's been about a 20-year span. We're like in year 3, right? But I think back to the old days of SMT and, you remember the Surface Mount Council that was created in order to help promulgate SMT in North America. And they did a phenomenal job. And we're fortunate at PCEA that we have actually the same person, Phil Marcoux, who was one of the folks that led the Surface Mount Council. In fact, Phil is credited with putting the first SMT line in the U.S. Phil is chairing our AI and electronics task group. We published a roadmap for AI that's available at the PCA.net website, and we're looking at doing a series of workshops at Epoch International. Phil's now the GM there at the Silicon Valley shop. We're looking at doing a series of workshops this year to help our members understand how to implement AI into their facility. And we're really looking forward to using Phil and his team as sort of a test case as to how to do this. That's really his mission here over the next couple of years.
Yeah, it's interesting when I look at AI and inspection. Use that as an example. The early days of memory chips. I remember we used to sell equipment back in California when we had memory chip manufacturers in our state. There were armed guards and metal detectors, not to scan you when you come in the door, to scan you when you leave the door, because people, employees and vendors or whoever, visitors would, grab a handful of SIMs or whatever and stick them in their pocket and walk out with, $10,000 worth of pawn value. And, it's crazy to think. And thanks to Moore's law, I guess, memory is cheap. It's unfathomable, the scale. We keep coming up with new definitions. It was, bits and bytes and megabytes and gigabytes and terabytes. And now just, I think there's a whole council that just comes up with new names for the new scale for memory. But that resulted in what I would like to refer to, and I don't mean it quite literally this way, is junk data, meaning we're collecting everything because we can. And, processing power is fast. Memory is almost free by comparison. So we're collecting teraflops worth of data. Humans can't discern teraflops worth of data in a generation. We can't do that. This is way too much data. AI came along at the right time for that purpose, because now with the right models, we can discern what data. We can look at a much wider swath of data. We don't have to say we're going to get 3 pieces and call it a good base of statistics. It's now we can look at all the data. We don't have to just take a random sample. We could look at all the data, super fast, super cheap, and I think that technology of quantum computing and fast, uber fast processing and cheap memory has really re-engaged and reinvigorated the whole idea of like AOI or SPI or whatever. Medical industry, I'm sure radiologists are probably a little worried right now. I don't know how many kids are getting into radiology school to look at what looks to me like the old televisions. When the station went off the air, we called it snow. It was just black and white dots all over because there was no signal coming out. To me, that's what a radiologist looks at every day, and they see patterns in that. AI can do that, probably way better than the best radiologists on the planet. And fortunately, I don't have a large medical audience on this show because I would have alienated a few subscribers. But apply that to our industry or any industry for that matter. It can see things. It could detect patterns and trends and things way better than we can. It has just this infinite resolution that humans alone don't have. So I think that's going to be an exciting time and a positive impact on our industry.
I do too, but it's going to take some time to build up the libraries,
Yep.
and especially if we're going to make them open source for companies to be able to leverage. One of the things that we've run into on the design side is that while ECAD companies have developed the tools to have AI or AI assist, the designers themselves are reluctant to use them. They're skeptical about adopting them. The job displacement concern, or they're skeptical about the reliability. And that's to be, that's to be understood. But one of the things I would like to see is perhaps a different approach to the model. Right now, it's sort of a commoditization approach where, hey, look, I'll sell you this tool, and I'll sell it to you, Cisco, and to you, IBM, and to you, HP, and it, and then it's not really trained for each particular OEM's process. Um, what we could do is instead leverage the knowledge of the engineers that are actually working inside of Cisco or IBM or HPE to train their models specific to their company. Okay, so instead of HP saying, "Okay, we're going to train this and then give it back to the CAD company to then sell to HP's competitors," instead it becomes more of a closed environment and it's unique to that company, but it's way more valuable, right? Because company A's processes are going to be different than company B's, and they're going to be different than company C's. That way, the IP remains internal, and this is kind of an audacious approach, but perhaps that engineer whose brain is being used to train it could then leverage that going forward and say, hey, look, even if I leave the company, since you took my knowledge, my own personal IP, and are using this for generations to come, maybe I get a residual. Like a music artist, right?
Right.
Who gets paid for 75 years after creating a song lyric. And that would be really interesting, okay? Because if you want to create incentives to adoption, that financial incentive may be one way to expedite it.
Sure. Yeah, that's a whole new way to think about engineering in our world, and that's not a specific path that's been followed before. I know we're running short of time, so I just want to ask a couple more questions. If you had to predict what's the one issue or trend that's going to dominate our industry over the next few years? Yeah, I started off this conversation saying, we don't make predictions, but I'm going to put you on the spot. I just won't follow up and say you were wrong or you were right. What is there a particular theme of issues or a single issue from your perspective that you think is just not going to go away? It's going to stay with us for a while.
Right. I think heterogeneous integration. I really think that, again, I go back to the 20 years or so of timeline, from a technology to be introduced to when it actually gets, mass acceptance. We were talking about multi-chip packages and MCMs back when I entered the industry in the early 90s. I think we're here. I think that is something that will permeate the supply chain in the coming years. I know that was talked about a bit a few years ago, and the chatter's sort of calmed down. But I think that's mostly because people are actually starting to use it, and we'll just see more and more of it.
And finally, it warms my heart to go to a conference and see young people there. And I'm seeing more and more young people. I will see more in a few weeks at Apex. Apex will have already happened by the time my audience sees the show, but I'm sure I won't be disappointed. There'll be even more than the year before. At SMTAI, I'm seeing it. I'm sure at your events, you're seeing that too. It's happening finally. What advice would you give to this new breed of young bucks that are entering our industry to stay ahead of the curve and remain competitive and in a very, very quickly evolving landscape?
Don't take no for an answer. I mean, it's okay to be a little bit rash and pigheaded. Okay, be nice, but be curious.
Yeah, I think Steve Jobs coined that at a Stanford address that he was giving. I think he said, no, well, it was Steve Jobs. He probably was inspired by that somewhere else, right? He was great at seeing technology and went, I want that here, right? Like the mouse, for example, that's Xerox PARC, the graphic user interface, Xerox PARC inspired. And he just said, no, that's a small use. I see a big use. So there's nothing wrong with that. But yeah, I agree. I think the advantage that I see young people, well, let me compare it to experienced people, the old sages of our industry. We tend, and I'm one of them, you're one of them, we tend to hear an idea that we've already experienced, and we will just very quickly go, no, that doesn't work. We tried it, it doesn't work. Great minds think alike, but let me save you some time, kid. It's not going to work. The young people don't have experience with that. So everything is possible. And sometimes it just takes a second bite at the apple. They were just off by 2 degrees. They just need to move 2 degrees to the left, and they got it. And I think because they grew up in an era where information was very easy to get. We didn't grow up in that. It took a lot of energy to learn, to research, to actually read pieces of paper, and magazines like yours and shows like yours and others that, we had to, it was a huge investment in time. That information is on demand now. And it's they've learned differently, and they learn to learn differently. And, we are based on experience, and they are more based, I think, on anything is possible. So I think that not take no for an answer is great advice, because sometimes the no is really more accurately not yet. And the naivety almost, and maybe a little bit of arrogance, but certainly the naivety is crucial for revolution, even evolution, but a revolution in particular. Without that, why not kind of mentality, we won't get the revolution.
Yeah, I think if you look around, Mike, look on your desk and look at how many different just speaker technology, right? So I'm in the Boston area, and the Boston area has been traditionally one that was very advanced when it came to acoustics. And we know many of these companies, companies like Bose now have grown out, and they're huge, billion-dollar, multi-billion-dollar companies. But there are so many other guys that have popped up over the last 10 or 15 years that are growing and growing and growing, and we're seeing this at our conferences, right? All these OEMs that we've never heard of are showing up, and they're all folks who are under 35, in some cases under 30, that are driving them. Same with the supplier side. There's at least a dozen ECAD startups. It's the most I can remember, since before I actually even entered the industry. That are, a lot of these are AI based, but they are engineers that worked for a couple of years in the industry and said, I've got this problem. There's no easy solution. Maybe I'm just going to go create my own. A lot of head scratching, like, why are we doing this way? I'm just breaking my back doing all this really manual stuff when I think we could automate this, and I think I could do it better. And I love that kind of curiosity and that passion, that ingenuity. I would say to those folks and everybody else, though, is that make sure that your source of information is legit, right?
Yeah.
Because you can go on YouTube and Reddit and all these places and ask a question and get a bunch of different answers.
Yeah.
That's
true.
where you and me can, right?
Right.
That's where the old guys matter. And I would, that's where you can go to the PCB East or PCB Detroit or PCB West, our trade shows, and or use our website to meet folks who, they may say, I've tried that and it didn't work, but they might also be able to fill in the blanks as to why they think it didn't work.
Right. Yeah. They leave clues behind. Yeah, absolutely. Well, Mike,
maybe what you needed to make that work didn't exist at the time, but it does now.
Yeah. Yeah. I think it's a definite blending of older, younger. I think that is the perfect blend, and to me, I in my whole life experience, I have what I refer to as a reasonability test. And if something just doesn't sound reasonable, I look at it way more skeptically. But it's usually, it's reasonable to think that we can work around a problem. Look at what mankind has done over the millennia. But anyway, we are out of time. For my audience who would like to get more information on PCEA and Circuits Assembly Magazine, if you are listening to this on your favorite podcast app, look at the show notes. I'll give links directly to both of those enterprises right there. If you're watching this on YouTube, right down here, just look down and you can see the show notes there with Mike's information on the association and the magazine. And Mike, I really appreciate the time. As always, my friend, I'll see you shortly. I think I'll see you in a
Absolutely.
a few weeks or a couple of weeks or something. So safe travels, and thanks for your generosity and sharing your wisdom and time with my audience and your audience too. So I appreciate it.
Anytime, Mike.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to click the like and subscribe buttons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every single month. And a very special thanks to the Printed Circuit Engineering Association's PCB Chat, that's Mike Buetow we've just been talking to, at PCBchat.com, and Ascendo Reliability at reliability.fm for syndicating the show. Thanks also for your questions and episode suggestions. Please keep them coming. I absolutely love to hear from you. Send comments or episode suggestions to Mike at MikeKonrad.com. That's Konrad spelled with a K. To learn more about the podcast, please visit our website, reliabilitymatterspodcast.com. So once again, thanks for listening or watching. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.